So for part C of this question is where they define this new function g of x as the integral from -2 to x of f of t dt. So we want to remember when we see that, what they're really doing is saying that f is g prime, and this -2 is irrelevant. So this is, fundamental theorem of calculus says that then a g prime of x is equal to f of x. That's just applying fundamental theorem of calculus directly to this one. This is usually called part 1. The derivative of this integral, we plug in the x there. So g prime of x is equal to f of x. All right. Now we need to, and then since we have a graph of f of x, our graph is actually a graph of g prime. So we can use that to answer questions about g. So since they ask us to find an absolute maximum on a closed interval, we need to think about the things that we need to do for that. So when we're finding absolute max on a closed interval, we need to find the critical points. We need to check the endpoints, which is something a lot of people forget to do on a closed interval when you're looking for absolute max. And you also need to make a table of values. And so this is another thing that is sometimes neglected when we're looking for an absolute max. Like, what really is the difference between finding an absolute max and a relative max? So if we are just looking for a relative max, then all we have to do is look for where f prime changes from positive to negative. But if we want the absolute max, we need to look at all those relative maxes and the endpoints, and just look to see which one's larger. That's what we mean by table of values, and that will give us the absolute max on that interval. So now, let's go looking for critical points. That's our first step here. But we're going to sort of narrow down our focus on critical points, because we have critical points of g, where g prime equals 0, here at x equals -1, here at x equals 1/2, and here at x equals 5. But only one of those could be a maximum, because we can only have a relative maximum when g prime changes from positive to negative, and that only happens here at -1. So the only critical point that we're interested in is x equals -1. So we're going to say that there's a critical point at x equals -1 because, oops, that's not how you spell because, I'm thinking ahead and I put a g, g prime changes positive to negative there. Or you could say at x equals 1 again if you want. I want to make sure that I say why x equals -1 is the critical point that I'm looking for, because this question asked me to justify my answer. So I want to make sure if I say something is a critical point, I say why it's a critical point. And that's why I want to make sure I include that little sentence there. All right, now I need to look at all the values for my endpoints, -2 and 5, and for my critical point. So let's start by looking at g of -2. That's the easy one to do, because if we go back to the original definition, g is the integral from -2 to x of f of t dt. So g of -2 is equal to the integral from -2 to -2 of f of t dt, which is equal to 0. And then, I can just look at the other values. G of -1 is equal to the integral from -2 to -1 of f of t dt. And so I can just look at the graph and find what's the integral from -2 to -1 of f of t dt. It's this little triangle, so it's equal to 1/2. So that equals 1/2. Now I need to look at the other endpoint, which is g of 5. So get g of 5, that's going to be, back from our original definition. You can also do this with the accumulation form, but we might as well just go back to the definition they gave us. It's a little easier. The integral from -2 to 5 of f of t dt. And so in order to do that, I have to go and add up all these areas. However, I've already done that. And it's very typical in the BC exam that if they have you do some, type of calculation like this, they're just going to use it again. They're not going to make you do it again. So we can come back here to where we found out that this integral from -2 to 5 back in part A was equal to 11 minus 9 pi over 4. And we can just use that here. It equals 11 minus 9 pi over 4. All right, and now what we do is we just compare these values and see which one's larger. Now, by the way, this is a no calculator section, but notice that until now, a calculator wouldn't have helped us to do this problem at all anyway. And we can sort of expect, even though we expect all the questions to be calculator active, they certainly can still ask us questions like this, where it's calculator active, but a calculator doesn't help you. We couldn't use a calculator, wouldn't help us with any of that. Calculator would help us a little bit here because I need to know if g of 5 is bigger than g of -1 or not. But notice it's a no calculator question. They expect you to know if this is bigger than 1/2 or not just by thinking about it. Well, so you can think about it by thinking, 9 pi is going to be a little more than 27. So let's call it 28 so I can divide it by 4. So this 9 pi over 4 is going to be approximately equal to 7. And that means that this number is approximately equal to 4. It's more than 1/2 is the important thing. So then we can say that the absolute max of g on -2,5 is 11 minus 9 pi over 4. And in terms of my justification is that I've compared the endpoints and the critical point, and I've justified why the critical point is the critical point that I'm interested in. So that is part C.